remember, you can do the thing no matter what you're doing. We should probably get off this. No matter what you're doing, no matter what's happening in life, I bet and I believe you can get it done. Remember, you can do the thing, which is great. Anyway, how are you all doing today? We are going. So last episode, we basically just went over Numa Demosa's help, and we're going to be doing basically the same thing as I said from last episode. This is going to take us forever, so we're kind of just doing this forever. It'll be fun. I'm excited. Yeah, so before I got in here, I was trying to figure out how to install it with Stack. And I wasn't able to figure it out. What the hell? No. So, trying to figure it out. Was not able to figure it out. Yeah, I'll spend like some time trying to figure this out. If not, that's fine. I will go back to doing help, which is fine because I want to learn Haskell and not learn how to do this. We can always do this off camera. Fuck you. Alright, I have no idea how to install it. That's fine. That's no stack install control.lese. Yeah, how can I not? What did I do on my laptop to get this installed? Because I can't figure it out. Like, fuck. Alright, whatever. We're gonna go back to help. That's fine. Alright, so guys, what we got done, we kind of just went down the rabbit hole of the functions. So we got to this thing. This, which is add neighbor, L, from the left. So we successfully did this. Now we're going through this. And so the dot notation is just basically the dots for function something. Composition. So basically, if I'm correct, so basically, let's say we have a function f, right? Then we have function g, and we have function h, and we're applying that to just say some input x, right? This is saying do function h, then apply function g on that, and then apply function f on that. And I believe with the dots, we can go like this. F dot G dot H. And then we can go X. And that way it just makes it a little bit easier to see, a little bit easier to understand. And I think my confusion was this, and then also F $G $H X. Both of them kind of get rid of parentheses. It's just in a different way. And this is saying basically do H then G then F, I forgot. What now? People need to fucking stop texting me. Jesus Christ. What does this person want? Do 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 do. But this is saying like that. Almost like with the monad bind operation, where it's like do this and then do this and then do this, but with the output. Alright, so we correctly, so if we go back, look at our notes. This is why you always write shit, guys. IX is the index to update at. I1 is the index of neighbor. F2 is the neighbor cell. Cool. So, and then, so basically IX, X equals index to update at. Need to stop doing slouching. My back's gonna kill me. Index to update. F0 is an anonymous function. F1 is two functions and the index of the neighbor. Add neighbor pair and F1. Great. Function to add neighbor. You know, I'm actually kind of getting like intimidated a little bit. Like seeing this, I was like, oh god, I would not be able to like redo any of this on my own, which is fine. Like, we're all learning. It's fine. Oh, by the way, I totally forgot. Moon Man, thank you so very much for the follow. I appreciate you. You are appreciated. Moon Man did follow me when I was offline. Moon Man was a great bloke. Is bloke the right word? Can I use that? Moon Man's a great person. He's fucking awesome. He had a dance off at his work, which he still hasn't sent me the video. So this is going... Oh, God. And then we have this thing, which I think is an update at. Oh, God. Yes, I know I'm streaming. Thank you so much for letting me know. Sets value. It applies function. Applies function. Okay, so... Oh my god, I've almost freaking gone through my coffee for today. Applies function. So this is IX. Oh, what's I? The hell is I? Do we have I? Do we have an I? Is the index. IX is then something different. IX is getter at index. Alright, so I keep looking over my zoo because that's where my laptop is. So basically, apply function this, and that. Using lens instead of modify L helper function, I've left the no lens function so you can see how it works. Well, I'm going to figure out then I should actually probably look at the modify L as well. By the way, if you guys aren't getting into coffee, you should totally get into coffee. Speaking of getting into coffee, the coffee brand I'm using right now is called Big Truck. Big Truck Organic. It's hilarious. Here's the story, right? Here's the story of a... I can't remember that. Anyway, I was at a coffee place. I was at a coffee place getting coffee, right? Buying coffee beans. At the register... And then decided to look over to the wall of coffee beans. And I see a coffee brand that said Big Truck Espresso. I'm like, I didn't try that, but I want that one. It was so great. Alright, so F0 updates a cell with a row and column. Takes X, which is the input from F1. X row 1 div width mod width. All right, I see. This is updates. Newman Demos, it'd be great if you also like put names in here, but I know you were doing this quick. So this is an anonymous function. So x is the output of f1, and f1 is the function. That takes an x, has north neighbor equals true, and x has a south neighbor equals true, I minus 1. So row is I. The index div width, okay. So f1 returns the neighbor pair. f0 acts on a neighbor pair. And then we go I, apply the function to that at ix and L. Holy balls. Okay, let's look at modify L. What does that do? Modify L. Update the list by applying a function at the index. We are given a list of A, a function of A to A, and the index, and return in a new list. Modify L, the list, the function, the index. Take n x's. Oh yeah, this is what it is. So if you look up on how to like kind of update a list, it basically is like you have to split the list up where you want it, reinsert it, drop the one you updated, then put it back together again. Okay, so this is going do this, and then I think it's basically like apply. Oh my god. Apply the dot on that. So if we go to a new page here, do 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 do, ba ba da ba da ba da da bo, do 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 da ba da ba da ba ba da. Have you guys played Trails in the Sky? It's a good game. Currently on the second chapter. I've stopped playing it twice so far. I do want to finish it, if I ever do. I don't know. It's a good game. Anyway, coffee's done now. Kind of disappointed. So IX, I1, F2, function 2 is the, right, is the bidirectional one. I1 is from here at the index. So we're basically applying. Oh, we're applying this function to here, I believe. Yes, and then this is being applied to this, and then L, which is on the cell list. Okay, this can take some time to understand. Why is this so confusing? Oh my god, guys. Man, this is confusing as fuck. Okay. So confusing. So confusing. But we can get through it, because remember, you and we can do the thing. By the way, t-shirts are available, $40. I'm not wearing one right now, but they're fucking awesome. Okay. The and. No, what's the and? Oh, right, and is something different, isn't it? Oh, yeah, and is flip. And is flip $sign. Oh, okay, I see. Right. And is flip with the $sign. So yeah, the $sign forces execution, so and is the other way. Using the lens to modify L, where F0 gives us the row and column. All right, so this one, IX, how do you the index where the setter is at, apply the function I1 to F2, or F2 to I1. F2, right? F2 is the function, so it's one of these. And I1. So we got the index. And I1 is the add neighbor pair, which is the index for the cell is at. And apply at the setter. Okay. Confusing as fuck. So I might leave this function, mostly just because we've been on it for such a long time, you know? But then at the same time, it's like, I want to understand this. Using the lens instead, modify the list once throw and column update functions. Then you know what I can do? Here's what I can do instead. Oh my god. Let's do this. Let's actually... I mean, I already did assign names to these, didn't I, last episode? So add neighbor pair, right? If... check if the move to the current cell is valid. If not, then return nothing. Otherwise, the direction, if north... so, if north, then we're saying... if we're moving north, and then we're saying they have a north neighbor, and then as well go up one, and then they have a south neighbor. This add bidirectional neighbor totally makes sense. I get this, but this is a return two functions on the index of the neighbor. So function on cell 1 and function on cell 2, and cell 2 is the bidirectional neighbor part. Got that. F0 is an anonymous function. Update the cell with the row and column. This is saying row of the cell. So we're given, so F0 accepts a cell. F1 returns a cell. Yes. Tuples. Do 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 do. Do 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 do. Ba ba da bum ba da do 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 do. Can't const tuple, therefore it makes sense to use tuples when you know in advance how many things you need. Oh, this isn't a tuple then, is it? What the hell? Oh, I see. This is a tuple. This is a tuple. And this means it's a function. Oh, guys, this is... oh my god, I figured it out. This is the record thing. This is records. The record syntax, motherfuckers. I think. Alright, I got it now. Haskell, record, syntax. All of this is coming together, everyone. Haha! Alright, so he's updating the record. Okay, I get it. So basically, this is going... we're returning a function that, if it's north, we're taking the cell. So x is a cell. So this should be an update to cell and not x. We're updating the has north neighbor to true and updating the has south neighbor to true. Got it. And the index is... I-1. So this is a tuple of functions, F1, F2. So basically, if we're like so let's say if we're updating this one, right? We would do this one, and it has a north neighbor. So this one would has n equals true. And then this one would go has south neighbor equals true. And then the index That is the index of the neighbor. I get it. So we're getting the cell and then the index of the neighbor. Okay. So basically, this is the function. So basically, this one is the function to update where we are. This is the function to update the neighbor. And then this is the direction of the neighbor. So F1 is function to update current cell. F2 is the function to update the bidirectional neighbor. I1 is the index of the neighbor. I get it. And F0, we have a cell, and we're updating the row and column. Okay. So this is going IX, which is the index of the setter. F2, which is the function to update the neighbor. I1 is the index of the neighbor. So we're saying apply I1 to F2, and F2 is this. I1 is the index. Oh, right. Okay, I get it. So if we go like this, IX, I1, percent sign tilde F2 is saying, run F2 with the input I1 at the list IX. Okay, I get it. So basically, this is going like, okay, I'm starting to understand this now. My list IX equals F2 at I1. Okay, I get it. Okay, so this is saying, here's where our setter is. I have no idea how that's actually figured out, by the way, but it's saying apply function F2, and here are the inputs, which is I1. Now, F2, no, not I1. It's saying go, wait. So we get it. It's applying F2, and F2 needs a cell. Yeah, F2 needs a cell. And F2 is a cell because this is the record syntax. Takes a cell to cell. I mean, it says it right here. An index. So it's saying grab this function. And I guess this would be IX. Oh, wait, what? Oh, no. Oh, is it this way? Is it like this? IX, I1, F2. Is it like that? Is it that way? Man, Nicodemus, why aren't you on here? Can't you help me? Anyway, I think that's how it is. I get it now. I think that's how it is. We can go through. Is the getter at the index? I get it. So I think this is saying apply F2 to the index here. So basically, I was wrong. This is not correct. This is my list at index I1 dot F2. This is what's happening. And so this is saying at the index, get the cell at this index and apply F2. Got it. That's what it is. So basically, IX, I1, modify F2 is equal to update the list at index I1 with the function f2. And so this is so basically ix I1 f2. This is basically update NEIGHBOR with bidirectional neighbor. Cool. And now we have ix I that f0 dot f1. Okay, so if we go to Haskell. Oh my god, I'm starting to slowly understand all of this. My god, this is taking forever. Why did you go? No, go away. Fuck you. Quicksort in Haskell. Taking order. PX is quicksort lesser P. Oh, haha, fancy. All right, let's go to. God damn it, guys. Dot is a function that takes a B to a C, and then we have a function that takes A to B, and we take an A, and we take a C, and returns a C. So basically it converts A to C. So confusing as fuck. I wish what Haskell dot. I know I read this before. And then the appear and after would take precedence for anything that comes before. So let's say put string ln, show 1 plus 1. If you want to get rid of the parentheses, any of the following work. Premise of the dot operator is not to avoid parentheses, but to chain functions. It lets you tie the output of what appears on the right to the input. Okay, I was correct. Sweet, I was correct. I like being correct sometimes, you know? All right, so now we have this behemoth of a function. So it's basically first f1. And we all know what f1 is. F1 is the function to, this is basically to apply, update the neighbor at the current cell. No, update neighbor of current cell. At current cell. F0 is update row and column of cell. All right, so that way it's been saying F0 dot F1. So F0 takes a cell and F1 returns. What does F1 return? A cell. Cool. And F0 takes a cell and F1 returns a cell. So F0 takes a cell, and with that cell it updates the row and the column. So, oh, I get it. F1 is just to get the cell and to get the output. So basically, so F0 dot F1 is basically update neighbor, row, and column. All right, so then from there, this and then returns us a cell. And so we have ix at I, at index I, which is what passed in. So we're applying, which is then f0 dot f1. I see. So this is a at index I update row column and then neighbor. All right, we're getting there, guys. So now I'm really understanding this. This took forever and a half. All right, so basically what we have is this is going at, this is updating the other neighbor for the bidirectional neighbor. This is updating the current cell. And then we're doing L. Oh, right. No. This, right. So the output of this function is, I think, a cell. The output of this function is also something. But we're applying function 1 to function 2. Oh, God, I really wish I had the lens up here. How do I install lens? Not cameras. LENS. Oh, import control.lens. Okay. How do I stack include? That doesn't work. What? Help? Oh my god. Stack. Help. I really want to figure this out, man. I know I did before. Install. Shortcut for build copy binary. Uninstall test branch haddock new. Oh, this is a lot. Help version, numeric version, VIX. How do I do this? Oh my god. Stack install. All right. I was right. I just have no idea what I need to install. What time is it? 11:34. I have plenty. So what do I install then? This LENS? Oh, hey! I got it to work, guys. That's what I have to do. So now we have to wait for this to download. While that's downloading. Right? Alright, while that's on, we got this. So this is updating the bidirectional neighbor. This is updating the current cell with the neighbor, with the row and column. And then L. L. This is the reverse. So this is saying L on all of this. Because it's the flip of the dollar sign. So the dollar sign would run this first, but if it's flipped, it's that first. So add neighbor. So on the cell list, index direction cell list. So this is saying the cell list and then update. Okay, I think we got that. How's this going? All right, internet, you can go fast on this. Okay, guys, we got through add neighbor. We got it. We got it, guys. We can do this shit. We got it. Where did we come from? Render maze takes a cell list and a string. Render row, render... Oh, this is the printing. Build maze. Maze... $ fill maze L from the left. Simply wrapping our maze into maze constructor because it allows us to write classes for it, etc. How are we doing with this? Almost there. What's this? Bracket $? Come on, bastard. There we go. Bracket $ Haskell. Infix. Oh, this is fmap. Right. $ equals fmap. All right. La-di-da-di. So we're basically mapping fill maze L on a maze. And a maze is a list of cells. It's a cell list deriving show. So basically, we're to fill maze on the cell list, and fill maze L does IO in the cell list. Generates a list of blank cells. So basically, for each number of cell, we replicate on fresh cell. So we have a generate of list cells. Then we traverse borders, list of direction. Oh my god. I know I did this before. Replicate. Oh my god. Replicate. Creates a list of length given by the first argument. Having the value of the second argument. Right. Take an int and an a. So this goes... I know we went over this last episode, guys. I'm sorry. Basically, we have a cell list. And a traverse. Class of data should be traversed from left to right, performing an action on each element. So on each element... 0 number of cells -1. Do borders. And we turn a constraint legal direction from a given index. So if row equals 0 and column pure east, do a east neighbor, do a north neighbor. Otherwise, get the random choice where R and Z is from index. So this basically sets up the IO direction in each one. So this is a list of directions. A is a list of directions. Then we fold L, create an index list of directions, then fold over it, adjusting neighbors to a list of blank cells. M, I, and D, add neighbor, L, M, I, and D, L, zip. Right, I know where we are now, and that's still going. So we have add neighbor, L, M, I, and D. Yeah, so fold L, fold from the left, takes a function, and the starting thing, right, zippity-doo-dah, zippity-day, my oh my, what a wonderful day, plenty of sunshine coming my way. It's zippity-doo-dah. Oh, yes, this zips them up together. I am correct. I remember also seeing that last time I was here as well. So zip, basically index from 0 to whatever with A. So this is A. So really we have fold L. Basically add neighbor. The starting, which is an empty cell list. And then we have a tuple of int and the direction. And so from there, that is basically generating the list, and then we're putting a pure on it since we have to return an IO of a cell. This is an anonymous function that takes a tuple of I and D. We're add neighbor L with the M, the index, and the direction. So basically this is being applied from here, and M is something. Fold L Haskell. In functional programming, fold or reduces family higher to function data section in some order to build a return value. This is opposed to the family of unfold functions. Return value implies a function trying a data structure. Right? So this is really cool that I have a example besides just like adding things together. So this returns a cell list, and basically this applies a function on a cell list already, and it's applying this function, which is pretty nice. And I think this is what I was trying to do before, I think 2 or 3 episodes ago, when I was like, I have this list, now I need to apply functions to everything. So fold is actually what it is, because this actually says process in some order and builds a return value, but the return value is a cell list. So this is what we have, empty cells. But it's on an F map, which is actually interesting. Create an index list of directions and fold over it, adjusting neighbors to the list of blank cells. So we did add neighbor with M, I, and D. Fold L, F, Z, and X. X's is a fold L of F, S, Z, and X. Come on, there we go. Yay! Cool, there we go. Stab! Wonderful. All right, so now we have that. Fold L takes a function, BAB, takes a B, returns a traversable, and a traversable A, and returns a B. So if we go to write fold L, L is a function takes a B and an A, and returns a B, takes a B, takes a traversable of A, and returns a B. So in this case, we have L, so a B is of type cell list, A is a tuple of an int and a direction. And then this function right here, from B to A to B, so takes a B, which is a cell list, right? So in this case, M is a cell list as well. And then this is the function. This is then a function takes B and A and returns B, so that's that. So M is that, an ID is a tuple of int and direction, and he adds neighbor to it. And add neighbor takes the M, which is the cell list, to update the index and the direction. So basically where we are in the current cell, and applies it. And add neighbor, we just totally went all over that, which is did now. Takes the cell list we want to update, takes the index, which is the current index, the direction where we need to go, and the cell list. Awesome. So we just kind of did that all, didn't we? We kind of just finished this, didn't we? So if I would make a I'm kind of curious, right? Maze. So we have build maze, right? Where is build maze being called, by the way? Where's main in this damn ass thing? Borders, fill maze, add neighbor pair, valid index, valid moves, from to index move, modify L, update L, fresh cell, render cell, render row, render maze, show maze, data direction, instance show, cells height width build maze. I don't know. Anyway, so if you take grade build maze, this calls fill maze L. So if we go to fill maze L, fill maze first calls a replicate, on a number of cells, and number of cells calls width and height. Awesome. And then from number of cells, it does call, where am I? Oh, replicate. Fresh cell. Then after replicate, we have traverse. Borders. Which sometime we'll call get choice random. And then this also called get index or from index. Wait, get choice rand would cause val. Oh my god, I've already fucked this up. So this is a giant thing, but we did get through this one. We did get through it. So I'm gonna go one more time through this, right? So we have fill cell, right? This is an F map, basically mapping fill cell over maze. Data types. The cell is a cell, show cell where. Take the cell, NSEW, north, south, east, west, row, column, we don't care, which is visited in depth. So this is just to make the maze. This is actually not how to traverse the maze. Onwards, which I basically believe takes a list of things and adds something between it. I forgot. Onwards takes a list of strings and makes one string with a comma with a delimiter. So basically we're taking cell. The hell? Takes an A and a list of A and returns a list of A. The hell? Oh, it's the cons thing, isn't it? That is known as cons operator. It is used to prepend a head element to a list. So that is a list, and x dot that is prepending x to the empty list, making it a list. Okay, so we're prepending. I see. So we're prepending cell to this. Map show boolean north, south, east, west, and then we're doing map show R and C, where show boolean is. If we get x, if x equals, if true, then true, if false, then false. Because we have to show the boolean. So we're converting the Boolean here to a string representation. And then we're mapping show over R and C, which are ints. We know that, and we're prepending cell to that. And then we're doing unwords. Create a string, it inserts, okay, this just inserts spaces. Alright, so basically we put in cell, that cool. Direction, north, south, east, and west, deriving show inequality. Type aliases help make code easier to read. We have a point and an index and a cell list. So we have to show maze, where we put a show on the maze, render maze. From render maze, we take a cell list and return a string. Unlines. So we map. Unlines. What's unlines? I know I looked this up before as well. Creates a string from an array of strings. So what's the difference that and unwords? I'm getting tired, man. Create a string from an array of strings and insert spaces. Oh, new line characters. Oh. Alright, so we're mapping render row. And we're doing unlines on that. Rows as chunks of. We're adding that to concatenate. Replicate with. Oh, right. This is to then adds the bottom border and corner. Yeah, I see. This is the bottom border. Because basically doing this, we're getting the rows, which is chunks of. Is that a thing here? Yeah, I didn't think so. Oh, data.list.split chunks of. Damn it. Fuck you. Data.list.split module contains a wide range of strategies for splitting lists. Chunks of takes an integer, takes an chunks of n splits the list into length n pieces. The last piece was shorter. If okay, so we're splitting. Where are you? Render rows, chunks of width and CS. So basically this is the cell list, and we're splitting chunks of into the width, which makes sense, of rows. Then we're rendering the row. Concatenate top with a new line, and then concatenate side. So take a list of cells and fuse the tops of all. So basically we're splitting this into the width, right? So for each width, we're mapping render row on it. And concat renders, accepts a list and then concatenates them. A list of lists and into one. Okay. Top unzip. So we're taking a tuple and unzipping it. Render cell. All right, cool. All right, map of render cell. How have I only been streaming for 37 minutes? That's not right. Oh! Oh, my laptop froze. Oh, my laptop froze. That's why nothing's happening. Oh, God, guys, if you've been talking to me, I'm so sorry. I haven't noticed because my laptop froze on me. Laptop, you're a dick. Okay. I didn't know that could happen. Fuck a duck. Has anyone been talking to me? Why did my laptop freeze? God damn it. Hold on. Wow, this sucks, guys. I'm really sorry. If you guys have been talking to me and I haven't been talking back to you, I am so insanely sorry. Because I use my laptop to know if anybody's talking to me or not. But if no one's been talking to me, then I have no idea. So I'm really sorry. I feel so shitty about that now. Wow, laptop, you're a dick. Okay. Anyway, great. Guys, I'm gonna end the stream here. Thank you all so very much for watching. What we got done today was we finally understood that the update cell function, this behemoth of a thing, I finally understood that. Finally understood how that works. God, it took long enough. So if I go like this, right? If I go to import control.lens, right? Type. Cool. That's what we get. So I'm gonna end the stream here. We basically finished that one, and now we're kind of again going through how he's rendering the maze and showing the maze. So next episode, you can expect us to finish rendering this, looking through how the render works on this, and then we're gonna go to the maze generator, but passing a configuration between functions. Everyone, lurkers who are lurking, thank you so much for lurking. Watchers who are watching, thank you so very much for watching. Bots who are botting, thank you so much for botting. Again, my laptop froze, so I had no idea what's happening. But I will see you all next week. Also, if you are watching on Twitch, which according to my Twitch thing, I have 0 viewers right now, I will be streaming later tonight at 8 to help Asmodan with more coding. So I love you all, and I will see you all either tonight or next week.